China Mobile.
Okay, good afternoon. Hope you have a good lunch. As Rick said, China Mobile has been in this SDN journey for a while, a few years. Actually, we are not like Facebook or Google or those companies that has a lot of software talent can develop from scratch, right? So actually, in the history of China Mobile, we almost always rely on vendors to provide the equipment and even the software to run the network. But as everybody knows that we run into difficulties because the cycle time is just too long. So just give you some glance of what the China Mobile operation looks like. So we have 800 million subscribers. This is a paid subscriber, not a free subscriber. So,
Not like Facebook. Yeah.
Facebook has 1.5 billion, but yeah, we are not that much. We launched a 4G network beginning of 2015. So just a year and a half. We have 300 million 4G customers. So 103 billion USD in revenue. And we have the largest 4G network, almost, I think it's more than 1 million base stations. So the network is tremendous. And also you can see some numbers that our data traffic is going through the roof, but the traditional voice and SMS messages flat, or even go decline. It's like everybody. Right. Okay, so we need our network to be more agile and more easily managed. So we have this NovoNet. It's very much like the AT&T's domain 2.0 kind of a thing. So it's a vision. It's not there yet. We are doing the trial. We study the technology, we do the trial, and do some experiment. Okay. This is general. I think we don't have to expand too much on this. Today, actually, we just talk about the Novo DCs. So it's basically the data center portion of this whole vision. So we probably is the easiest one to do right now. So this is the Novo DC architecture. Basically, is we have a data center, we have a commodity hardware. But also, because, Rick said partially wrong, we still have to rely on a lot of, we are not greenfield, so we have a lot of incumbent vendors. So like a firewall, load balancer, and things like that. Also, for each kind of a network function, we have different vendors. Some have a number of vendors. So you see the different color is a different vendor. So this picture probably show you a little bit more. But we still need to do some our own, like the controller and the cloud infrastructure, which is based on open source. Right. So there's some Chinese, but I just this is a controller based on ODL. This is the white box switch. The rest is not And the right on top is the novel DC SDN application. So basically, it's the orchestration and the management platform. So it's based on some open source, some are the vendor provided. We also realize that currently, if you want everything to be open, like this yellow line here, still have some way to go. So we accept that. So we have VNF, which is like a load balancer or the firewall, and we have their VNF manager, which is kind of proprietary to this vendor. So this like a green has this vendor, and different color is a different vendor, and they all have their own CLI or proprietary management interface. But what we like to do is that on the top level, which is has a standard like OpenStack has a neutron interface, and also we extend the ODL for SDN controller northbound interface. Also, we have this we call the service chaining interface. We standardize that, and we push at least in China, I think we have already the standard out there for people to develop application on top of that. So this demo today we're showing is utilize those interface as an example of application you can do. Well, leverage all this infrastructure underneath. And this is the actual, physical setup. So we have a few servers. We have a Tor switch and the core switch that make up the fabric. And we have overlay and underlay that make up the SDN network. So what we are doing is on top of this physical network, we develop some SDN scenario and do some logical network building. In the lab, we do the testing on this infrastructure. We test the OpenStack system test. There's a few numbers. For detail, I don't want to go through all that. And the SDN controller for this yellow colored block, the V switch and for the controller and the forwarding device, we do some testing on that. Also for the green color, we have the DNFs that we do some testing. Basically, we have this test bed made up like this. So what we're trying to do is build a logical topology. Say this is a tenant. Well, this network actually is for our internal use. So, but it's for like a different user of the internal network, like network management people or other the operation people that can easily create with a web interface. So basically, on this physical network, we create several instances of this logical network. So the demo we're showing you is something that goes through the steps that how we do this. Okay, here's the demo. So this is a web interface. This is a logical network. Before I I'm doing this, I just go through the beginning of this, how we can create this. So, like I'm AppFest. So I should register first. Give a simple password. So I'm creating a user. So this user may be one of the internal user. And then the first step is I'm going to create a virtual private network. So it's called AppFest. Okay. So it looks successful. So I'm going in there. It should give me a clean sheet of paper. The first thing I'm going to do is I create a subnet and just drop and place. So here I can define this subnet. 192. Okay. Actually, this physical network is in halfway around the world in Beijing. VPN into it, so I can access this network. And the hardest thing is to connect to it because the VPN is dropping all the time. All right, so I create one. Then I create a virtual virtual machine to connect to this one. So since I already created one of the network can be used in my account, so this is just use this one. And I want to use, I can select, there's several image I can use. I can use Ubuntu, Nastrom, or, well, I just use, I don't know anything else, I just use Ubuntu. Okay, then the CPU, it's just like a EC thing, right?
Mm-hmm.
And at this, we don't have external IP I can use, so I just click confirm. It take a while to have this. Okay, so it's automatically connect to this subnet. I can create another one. So this time I have it give you a different subnet. Four. Okay, I'll put another virtual machine here. And this time they have two subnets, so I'll put a virtual machine on another subnet. So basically, I'm on this the infrastructure I was talking about before. I created this 2 subnet. Now I need to use a router to connect them together. Now this is a router. Now I'll create a link between the router and this subnet. I'm going to create another one to this one. Okay, so this router now connect to this. Now see if I can ping the other. I can open up a console on this virtual machine. Just give me a oh, it's blocked. So this is a virtual terminal. Automatically let me. So, see, if I can pin the other one. What's the IP address of that one? Let's see, 42. So as you can see, it doesn't pin. So what I need to do is I click this link. It gives me this security group configuration. So this by default is only allow the TCP/22, which is the SSH, to go through. So now I'm going to force it to open up. So now it's all connect. I have to do the same thing on this one. It's kind of a response is slow. Okay, same thing. By default is only the SSH going through, so I force this. Oh, now it pins. Right. So now. So for more elaborate, there's another this load balancer. Excuse us that we don't provide the English. It's just Chinese right now, so I complain to them because there's no time to change it. So this thing is a load
I
balancer.
trust you, Robert.
Right. So I'm going out to, I'm logged into a different user, which is already have a network created. So basically, this is more complicated network. This user, we have is an access point. So this one, you can see has a, it has an external IP address. So basically, this is a pool of address to map to whatever the internal IP address. So right now, I can say, I want this one. I'll give them some suggestions. This user interface is kind of not very friendly. When I put my cursor on it, it just pop up something which is not what I intended. So I'm going to bound a external IP, which have given me this menu, so I can select. Since only this one is available, so successful. So you see the little E here means this machine has assigned an external address from this external pool, right?
Wow.
Okay. My colleague also created this load balancer, which is more involved. You need to basically configure that in the back end. But I can show you what it is. It's actually very simple. We can select. There's actually a menu. You want to use H3C, which is a company that HP and
Yeah.
right. You know the history. Probably.
And it's an open flow conformance switch. Yeah.
Yeah, it's a load balancer. Okay, and this one has already assigned the external IP pool. So basically, the load balancer is from externally. If you access to this, actually it goes to this is the member of the load balancer has these two machines that's already mapped to it. So if I go to the terminal, I can SSH to a machine that's outside of this network. Okay, so this is a machine that's not in this the network I created. So if I go to what's the 90, right? If I go to access this load balancer address, which is this one, and it's basically a web page. Okay, I got some junk replied. It's this address. So this is one of the member of this network, right? 192, 192, 168. point 2.4. So if I access the same one again, it gives me a different address. So basically, this shows that the load balancer, when you try to access this this web server, which is put load balancer in front of it, but on the back is actually this two server that serve the same, but it gives you a different address. So see this. So basically, the load balancer spread the load to a different. So every time, right now I set this as a round robin, I think. Yeah, this load balancer is the scheme. The load balancing scheme is a round robin. So I can add a different one, another machine. To the same, to this .2 network. Now, it give me another automatic assign the .6 address to it. Now, since this is not the member of this, I add another member. See, the other two is already the added. Now this one is not added, it's automatically. So I assign the weight as 1, so you can send a different weight. I'll pull the HTTP, which is the web server. Oh. I think I need to security. Some reason doesn't work. Let's see if it's a console. I need to probably get modify the web server. I'm going with the time. I think this is not a problem, but just Anyway, basically that's the procedure. You add another member to your load balancer, so you can have 3 web servers instead of 2. Somehow that doesn't allow me to do that. Okay. It doesn't allow me to specify the one. Let me see if I can get a different response. Now I have 3 members to respond to this inquiry. So I have .2, .4, .6. So there's more elaborate thing to do. Like here, you can define the group policy, which is define this link and this link. Right now, I just show you is I can define this. This is per VC, right?
Mm-hmm.
But if I do this, I can do it for this particular group.
So you could make a standard, and then if you had to give more different attributes to one of those connections, you can go from there.
Right. I can add another group definition, group profile, which is like this. But this is only for that particular VC. This is for this particular subnet. I can, but that is more involved. That I need to define.
Robert, how much time is this application saving your company in terms of what? Talk about how difficult it would be deploying it the other way.
The thing is that this kind of internal requirement change a lot, right? It's best for them to have this is just like a develop a web application or develop some kind of a management application. If it rely on vendor, you basically do a bidding. It's a long process, and then maybe a few months, if not more. But if you do this, it's much easier to. But at least you need to create this platform to allow people to do that. That's what.
Yeah. So your data center services, you're a lot faster for your customers. You're a lot more nimble. You're able to save time, cost through this.
Right.
Wow, that's great.
Also, actually, just a minute. Okay. So this network. Right now, we just have a load balancer and router and maybe firewall. In the future, we want to have more of this. This basically is the virtual network function, right? Mm-hmm.
You could do like intrusion detection or whatever.
So, but that so basically, this is let's go to my last page. We go back to my presentation. So we have this. Basically, what we like to do is we drive to standardize on the top. The APIs, the northbound API. We are using Neutron. This web interface looks simple, but at least, but underneath there's a lot of API to have the controller API, have this service chaining API, which we create and standardize. Also right. So, but we are also seek the partners to develop SDN applications, also the VNF, so that we can enrich our platform and more application on top of that. So that's
wow.
Okay.
So this is an internal corporate site, right? So your corporate business partners are using this rather than your customers. Is that true?
Right. This currently this for developed for internal use. But once we have more features, maybe we can extend it to
What sort of growth have you seen with the use of it? And how many tenants do you have?
well, it's none. Right now we this is in the lab.
Early phases.
Right. So it's not live yet, not in production yet. We are still in the process of development. Also, I think probably you have heard we are making open source. We call it OpenO, which is an orchestration part, right? As an open source effort, that's China Mobile and a few other partners that initiate at ONS. So.
How many of you have ever provisioned a website like with GoDaddy or whatever and have used cPanel? Okay. What's great about cPanel?
You can do everything from one spot.
Yeah, from one pane of glass I want NoSQL, I want MySQL, I want MS, I want LAMP, I want this kind of PHP, I want this kind of and basically configure everything, press the button, and less than a minute your instance is ready to go. And I think that's the direction that SDN should be going, that you don't have to know Perl, you don't have to know Python, all these other things. I need a load balancer. Nobody says I need an internal combustion engine of 2,000 cc's and 100 foot-pounds of torque or whatever. I need to go to the mall, So
this is for basically for the telecommunication basic infrastructure. What we are creating is that you have load balancer, you have firewall, you have all the internal IT network. For this is maybe for enterprise, right? That's you have all this. Just some very simple component that you all need in your enterprise network, but right now it's not available for.
What's your roadmap for this? When do you think customers will your deployment or? They don't let you make that.
My name is Robert Chen. Just for our introduction, I'm based in Milpitas, California. It's our Silicon Valley office. Basically, our colleague created this in Beijing, in China. We work together on some of the initiative on SDN, but the guys that did this cannot come here for the presentation, so I'm kind of helping to do that. But we can log your question, so we can go back to. So if you have any question, just send Robert Chen at chanmobile.com.
Other questions for Robert? Yeah, please.
So on the logical network you showed us, how much of it is pure application? I know probably from the physical network to the logical network, is there a pure virtual component that you showed, like the load balancer? Is that a real load balancer in the physical network, or is this just a
this my understanding, this is a combination of physical load balancer, physical router. I can go back to the this. Some are actually like a router. Actually, is a physical component, and the load balancer is actually is virtual. Actually, but it's provided not by ourselves. It's not like we pull a open source load balancer to instantiate that. It's not actually. It's a commercial load balancer. But they provide us with this API, so we can configure it.
So the attributes of that particular one, and it's like the drop down that you did for the switch. eventually you would have a variety of different. Yeah.
So we like to have this interface, the user interface, very simple, just like maybe it's not really great kind of thing. Maybe it's local operation is probably better, but since my VPN is kind of remote, so response is not very great. But what we like to have a consistency of this user interface, so we can you add load balancer, you add a firewall, you add a VC, just like maybe later you have other component at the same way. But actually the SDN controller and the service chaining and kind of a management doing their work down underneath. So we hide this complexity.
Yeah.
From the
So basically what you would be able to do here is, let's say you have, different parts of your infrastructure, and in this section you're using more legacy equipment with physical load balancer, and in this part you're using more SDN equipment, and you're actually setting flow tables to create load balancing functionality. But from the top, from the application, it is all the same.
It doesn't care if it's hybrid. Yeah,
exactly.
but it is. Yeah, that's a cool
So that's
deployment
why-
path. Yeah.
That's what this shows. Maybe, yeah. Basically, we want to have this consistency on top, but this, this may be one vendor that has to provide the proprietary API, but to the top should be the same. That's why we standardize on that. And for this SDN controller, all this is if we can have the standardized open interface, then we use that. But if not, then we have to.
Just go with APIs.
The world is not perfect. We want to have all open, but somehow but we have to.
Got equipment there. Yeah, that's well. Wow. Other questions for Robert? Well, this is exciting. I think all three of the demos that we've had today have really given us a sense of where these projects are going. We're no longer talking about science fair and proof of concept. We're now looking at deployments. We're looking at taking time out of processes that took days or taking minutes. Deployments that took 6 months are now taking 3 or 4 weeks. Not so much a savings of equipment, but speed and agility seem to be where the network operators are getting the most out of SDN these days. And so, and what Mark was talking about earlier, just a few moments ago, this transition from having a legacy environment and not really having the freedom or the checkbook to rip everything out and start from SDN scratch, so to speak, and how to get to a more SDN-powered environment in a mixed hybrid mode is really one of the key challenges that our operators are facing. So let's thank Robert and the China Mobile team. Thank you very much.